Yeah, hi everyone, and welcome to chapter 5 on pre-training large language models. So in this chapter, we are going to finally put together all the building blocks we worked on so hard in the previous chapters. That means the data loading from chapter 2, the multi-hit attention mechanism from chapter 3, but then also, of course, most importantly, the GPT model architecture from chapter 4. So here we are going to put them together to pre-train this GPT model that we just implemented in chapter 4. And we will do this step by step. So first, we will be implementing the evaluation of generative text models. And then, that will help us to measure how good the text is that the model generates and how we can optimize this. But in order to measure how good generated text is, we have to actually get the model to generate text in the first place. So in this first section, I want to briefly go over again how we use the GPT model that we have just implemented in chapter 4 to generate text. So let me see if I have some nice figures here. So in the previous chapter, in chapter 4, at the end of it, we discussed briefly how GPT models generate text, and that is one token at a time. So if we have an input context, we generate the next token, and the next token gets then concatenated with the input to generate then the next token and so forth. So it's like an iterative process. And then what we talked about was this figure, which looked a bit complicated at first, but I hope it was not too complicated in the end once we implemented it. So what we are seeing here is that we have a number of input tokens. They get converted into token IDs. Then they go through the GPT model and we get out a tensor consisting of 4 rows. So each row corresponds to one of the input tokens. We take the last row, we get the probabilities for each position here, where the positions correspond to the number of entries in the vocabulary. And then we extract the largest position here, which corresponds to the token ID that we want to generate. And we convert this token ID back into text and then have the generated input text. So in this case, it's only one token we generated. Now, going to chapter 5, I won't go over all these here, but where we are, maybe in the big picture sense, we are now finally implementing the pre-training, and it's done in several steps. So there are 7 steps to it. And by the way, maybe before I continue with the text generation, I wanted to say we are pre-training this model here, and later on we will also be loading pre-trained weights from the OpenAI GPT model. So everything we do now is for educational purposes, the training and everything, and then we will also load the pre-trained model. But anyways, continuing with what I just talked about, the generating of token IDs or generating of tokens. So here the figure is very similar to the figure we just looked at in chapter 4. It's just visually a bit differently laid out. And so again, what you are seeing here is some input text for input tokens 1, 2, 3, 4. We will implement a function called text to token IDs, which will take this text and convert it into token IDs. And this is exactly what we have seen in chapter 4. These token IDs go into the GPT model, and the GPT model creates this output tensor consisting of 4 rows, similar to before. And then we will have a code that converts these tensors into token IDs, and then we will have a function called token IDs to text, which will then convert the token IDs back into text. And what you're seeing here is just like a different visualization of what you've seen in the previous figure in chapter 4. It's just a bit more compact, and the focus is here on these 2 functions, text to token IDs and token IDs to text, that we will implement just to make our life easier when we are implementing the training function, so that we can use it in between to print out some results and see what the model is generating to get an idea if it's actually generating useful text or not. So with that, let's maybe get started and just get coding, because I think then these things will become more clear. And what I like to do is, when I start a new coding notebook, I like to import the libraries that I'm going to use in this notebook at the top, because then, for example, in a few months when I revisit this notebook, or maybe next year, or if you are revisiting this, you see exactly what software libraries I've used. And if you have a bug or anything, or things look different, one good place to start is to make sure you have similar libraries installed, because sometimes libraries get updated and they change functions and things might break. In this case, these libraries are all very mature. They don't change much at all anymore. So technically, you don't need to have these exact versions. Let me just print this out. So matplotlib is just a library for plotting the graphs later when we plot the loss functions to make sure the model trains well. So for now, it's a simple, or not as simple, it's a very sophisticated, but it's a basic way of just making plots in this lecture. NumPy is an array library that is used by PyTorch and TensorFlow. TickToken is our tokenizer from chapter 2. Yeah, PyTorch, we don't need to talk much about PyTorch because we have used it now so much that I think it should be clear. And by the way, I'm using PyTorch 2.6, but when I started writing the book about 1 to 2 years ago, it was PyTorch 2.0. I tested all the code on 2.0, 2.1, 3, 2, 3, 4, 5, 6. It works all the same. So, it doesn't really matter which PyTorch version you're using. Older ones are also fine. With TensorFlow, that's interesting though. You don't have to have this exact version, but you need to have a version of TensorFlow. Why? I mean, this book is not using really TensorFlow. We are implementing everything in PyTorch here. But so I mentioned briefly when I scrolled through the figures here that we are going to load pre-trained weights from OpenAI. And back then, when OpenAI generated the GPT-2 model, they used TensorFlow. Now, TensorFlow is not very popular anymore. I mean, not at least as popular as PyTorch anymore. It's also not super actively maintained, in my opinion, because it took a long time, for example, to even get NumPy 2.0 support in TensorFlow. And I know that not a lot, but a few readers had issues with TensorFlow on Windows. It's not everyone. It's, some people had some incompatibility, so I don't know exactly why. But I feel like, TensorFlow is sometimes a bit tricky. So right now, if you get an issue with TensorFlow here, I would say don't worry about it yet. We don't need it yet. We will need it only at the very end of this code notebook. So you can, continue and maybe revisit this later. So it will be just at the very end when we are loading the weights, because we only use TensorFlow here to briefly open the weight files that OpenAI shared. And then we will convert these weights into PyTorch. But for this intermediate step, for just opening the files, we will briefly need TensorFlow. But even then, in case you can't get it to work, if you go to my GitHub repository for the book, I do have a bonus section for chapter 5, where I also implemented it with the Hugging Face Model Hub, where you can also load the weights with different libraries. So there are some alternative weight loading strategies here I've outlined. And the reason why I'm not using those in the book is these are not the official ones by OpenAI. So I preferred using the official ones that OpenAI shared, the official weights, and they happen to be in TensorFlow. But this is a good backup solution in case your computer doesn't support TensorFlow for some reason. But let's cross this bridge later when we get to the section on weight loading. For now, maybe if this doesn't work, just comment it out or something like that. So then to continue, another thing is we had this, there we go, this configuration file here. So this is from the previous chapter. I will make some small modifications. I will change this to 256 because I'm running the code here on an old MacBook Mini, old MacBook Air from 2020, which is not very powerful. And it has limited memory, compute memory. And the longer the context size, the more compute memory you need. And so I'm just making it compatible to my computer here. Chances are you have a newer computer where it's just fine, you have more RAM, maybe even you have a GPU. So the code we will run later will also optionally run on GPUs. But just to make it compatible to most people's computers, I thought erring on the lower end might be a better idea, so you don't get any issues, but feel free to also try out larger numbers. And that's basically the small modification I'm making here. And then we are going to implement our GPT model. So for that, we do from previous chapters, import GPT model. And I should say, in order for that to work, you need to have a file here called previous chapters. And so here it's just a file I created. What I put in here is all the code from chapter 2, the data loading code, the dataset class and the function to create the data loaders. Then the multi-head attention mechanism from chapter 3 that is used for the GPT model. The building blocks, the placeholders we replaced with the actual functions, the layer norm, the GELU activation, the feed-forward module, the transformer block, and everything that goes into the GPT model. So that's the main thing here, and this GPT model depends on the other ones. So that's why everything is in here. And I also added this generate text simple function from the end of chapter 4. So this is all the previous code. I just put it together into this file here because then we can import. So here, this will import the GPT model from this file. So yeah, just make sure you have it here. And then we are going to use the model, so torch manual seed, so that we both, you and I, get the same results. And then the model itself. So we will, there we go. We will use this dictionary file. And then one thing I forgot actually in chapter 4, sorry about that, the evaluation mode for generating text. So eval, what it will do is it will kind of disable all the random elements in a model. And in chapter 4, we talked, I think it was chapter 3 actually. In chapter 3, we talked about dropout. So dropout is a random dropping of nodes during training to prevent or reduce overfitting. But we don't want this random behavior during inference when we generate text. So we want to disable it here. So that's what we're doing. We're disabling dropout so that there is no random dropping during inference. We only need it during training. Now, this one, eval, probably stands for evaluation or something, but it will just, it's like, you think of it as an inference mode or prediction mode or something like that, where we don't want randomness. So that's what's happening here. The reason why I'm using the semicolon is I should, of course, import PyTorch. For this one, we need PyTorch because I'm calling torch.manual. So if I don't do the semicolon here, you will see it prints the model architecture, which is quite nice. You can see what the model looks like, but it is also creating a lot of clutter here, which is why I'm adding the semicolon. And by the way, if you want to make the model ready for training, we will do that later. The opposite of eval is train. So that's the opposite. So to make it trainable again. Okay. So that is the model itself. Now let's get to the functions. So let's do this one by one. We use tick token as our tokenizer. And then from previous chapters, we implement the generate text simple function. What we do is we have the text as input to our text to token IDs, the tokenizer itself, and then we use the tokenizer to encode text. So that's what we're doing here. Here we're adding a batch dimension because our model was implemented to work on a batch, not on a single Python list or tensor. So here that's what we're doing. Nothing too special. Let me actually initialize the tokenizer and give some text to the function just to make sure it works. So let's try this actually out in practice. So we do start context and then tokenizer. Let's see. So yeah, it's converting correctly text to token IDs. Now we implement the opposite. So what we do is we will implement the token IDs to text. And here it will receive the token IDs that we just generated as input. So let's maybe save them here. And it will remove the batch dimension because then we can convert it into a list because the tokenizer itself works with Python lists. And by the way, this is exactly what we have done at the end of chapter 4 here when I did the squeeze to list and everything. So this is the exact same thing we're doing here. So the squeeze to list essentially. I'm just packaging this in a function so we can reuse that without having to type it every time. And then a tokenizer. Okay, so yeah, we converted the tokens back into text, and these are our convenience functions. Yeah, the main part is essentially setting up these functions, and then we can also use the generate text simple function, which we implemented also at the end of chapter 4. That's from the previous chapters, or we have it also here in chapter 4. And with that one, we are here using our text to token IDs to create the token IDs. We say how many token IDs we want to generate, and then yeah, the maximum context size of the LLM. So let's run this and let's take a look at the token IDs. So we can see this should be 14. So it's a double list, so I can actually squeeze that to make it a single list here, and then I can also just do shape. It doesn't matter. So we see we have 14 token IDs, and the number 14 comes from the fact that we have 4 input IDs, 1, 2, 3, 4, and then we generate 10 new IDs. And now we can then use our text to token, token IDs to text function to convert these token IDs back into text. So let's see what happens. It's missing the tokenizer, of course. So what happens is, yeah, we can see the first 4 tokens are indeed correct, that these are the ones that we provided, of course, but then everything else doesn't really make sense. So we can see it's, gibberish. So what happened here? What happened here is that the model, we initialized it with random seed, we haven't trained the model. So if we want the model to generate coherent text, we have to show it how, and that is essentially the training. But before we do the training, we still need to kind of have a numeric way of visualizing it, because right now we as humans, we look at this and say, oh, this doesn't make sense. But how do we actually quantify this? How do we measure how good this is, right? So because we need a measure of this in order to optimize this measure. So in the next videos, we will see how we measure the quality of this generated text.
Get this book at Manning.com.